Hello, today I want to show you the best way, the simplest way to differentiate between valence, oxidation number or oxidation state and radical. Many students, when they are studying chemistry, they confuse a lot about valence, oxidation number and radicals. Today I want to make it very simple and clear to you. So you're welcome to this lesson. Valence is the combining capacity of an element, or combining ability of an element. In another language, you can say valence refers to the number of electrons which are needed for to be shared in the chemical bond formation, needed to be transferred. They just can be transferred from one element to another. For example, the numbers that are transferred from metal to non-metal, and the numbers that are received by the non-metal. So those number of electrons which can be transferred, which can be transferred or donated, or which can be received, or which can be shared in bond formation, they are called valence. So for example, here we have calcium. Calcium is 2,8,8,2. So calcium is unstable. Calcium is an unstable atom. Why? Because it is in the outermost shell, it is not 32. You know, we know that the first shell should have maximum 2 electrons. If it has less than 2, that atom is unstable. For the second shell must have maximum 8 electrons. If it has less than 8, that atom is unstable. The third shell, maximum 8 electrons. If the atom has less than 8 electrons, it is unstable. And the fourth shell, or the fourth energy level, must have 32 electrons. If it has less than 32 electrons, it is unstable atom. So for example, here is calcium. Okay, calcium, it is 2,8,8,2. It is ending with 2. The outermost shell electron is 2. Now look, the outermost shell is 1, 2, first shell, second shell, third shell, fourth shell. The fourth shell should be 32, but it is 2. So calcium is unstable. Okay, let me give you another example. Maybe it is chlorine. Chlorine is 2,8,7. Okay, so the outermost shell is the third shell, which is 7. Now let us refer to the formula. That third shell should have 8 electrons, but here are 7. So this one is unstable. It is unstable because it is missing 1 electron. Yes, this one was missing 6. Oh, need to remove this 2 so that it becomes stable. Okay, now let's say sodium. Sodium, it is 2,8,1. Look, at the third shell, the outermost shell is 1, while the third shell should have 8 electrons. So this is an unstable electron. So here I was trying to let you know about the stable and the unstable electron. For the stable atom is including neon. Neon, it is 2,8,10 electrons, 2,8. You see, the second shell have 8 electrons, maximum 8 electrons, and it has maximum 8 electrons, full. So it does not need an electron or to gain or to lose electrons so that it becomes, but it's now stable. Argon, it is 2,8,8. So here in the third shell has 8 electrons. Look at the third shell, maximum 8 electrons, and here are 8 electrons. So it does not need an electron to become to gain or to lose electrons so that it becomes, so it is stable. Now, my friend, all stable atoms, they don't react. They don't need to give or to gain an electron. But for the unstable, all unstable atoms, they need to gain, either to gain or lose electron. Now, to specify, metals, they are found in group 1, they are found in group 2, group 3. Here in group 1, we have lithium, we have sodium, and the potassium. But in group 2, there we have magnesium and the calcium. Okay, group 3 we have boron and aluminium. Look, the outermost shell in the electron, sodium and potassium, end with 1. So the outermost shell is electron is 1. Outermost shell electron is 2. Outermost shell electron is 3. Oh, let me show you. Sodium, okay, sodium we have already shown, this one. Maybe potassium, okay, potassium 2, 8, 8, 1. You see, it is ending with 1. The group 2 end with 2. Group 3 end with 3. Let's say maybe it is boron, okay? Boron, it is 2, 3, because you have 5 electrons, so it is ending 3. You see? So metals, group 1, group 2, group 3, they are unstable. Why? Because they end with 3. So they need about 5. For example, group 1 need either, we can say 7 electrons. Or we lose, either we lose this one or we gain 7. Here group 2, either we need 6 or we gain, we lose this 2 so that it becomes stable. Here in group 3, all of them, either we need 5 or we need to remove these 3 so that it becomes stable. So in a simple language, you cannot take many electrons out of this little few. So either here, so in metals, because they are few number of electrons, so according to ionization energy, so now all metals will need to lose the electron or electrons to become stable, all metals. And non-metals from group 5, group 6, group 7, they need to gain either 1 or 2 or 3 electrons to become stable. I think that is clear. So now, those number of electrons that are needed to be lost, needed to be gained, or needed to be shared in order to form a chemical bond, those are called valency. So valence is neither positive nor negative. It's just the number of electrons that are needed to be gained or lost, only that. So it is not neither positive nor negative. Now, oxidation number or oxidation state. For oxidation number refer to the number of electrons that are lost, gained, or shared in the formation of chemical bond. So they have already lost, they have already shared, they have already gained to form a chemical bond. For example, in this compound of sodium chloride. Sodium chloride, before it was formed, here sodium and this is chlorine. Sodium was 281 while chlorine was 287. You see? Now, sodium as a metal lost this electron to chlorine. It transferred its electron to chlorine. The electron, this one electron, was transferred here in order to make this stable. So now this becomes 2,8. You see? Now it is stable. Okay? Now this, when it is stable, it's called the sodium ion. It has lost 1 electron. And now this becomes stable by becoming as chloride ion. How? It becomes 2,8,8 because it has gained the 1 electron, and it is written like this. Now, oxidation state, we are talking about the number of electrons that has been lost. So look, oxidation of sodium, it lost 1 electron. So oxidation state of sodium is now, it is positive 1. It is positive 1. And oxidation state of sodium of chlorine is negative 1. Are we together? Yeah. So in simple language, considering the simplest way to know the oxidation numbers, look at the group 1 in group 1, group 2, group 3, group 4. Group 1 has oxidation number of positive 1. Group 2 elements have oxidation number of positive 2. Group 3 elements have oxidation number of positive 3, including chlorine, including aluminium, boron, including here calcium, magnesium, including lithium, sodium, potassium. Group 4 is carbon, silicon, so they have either 4, positive or negative, okay? Now group 5, including the nitrogen and the phosphorus, they have oxidation number of negative 3. Why? Because they are gaining 3. Here, they have lost 1, positive 1. They have lost 2, they need to lose 2, lose 3. And here, group 6, here they will have negative 2. And group 7, here is negative 1. Why? Because they gain 1. Group 8, they are stable. They don't need to gain anything. So their oxidation number is 0. Oxidation number is 0 and the valence number is 0. That's why group 8 is called the group 0. Yes. Now about radical. Talking about radical. Radical is a group of elements which act like a single atom. Radicals, group of elements which act like a single atom. Or we can say is a group of atoms. Here we have this one. It's called the nitrate ion. You see, another maybe this one is called the sulfate ion. Sulfate ion. We have another maybe is called the ammonium ion. We have this one. So here group of nitrogen, 3 oxygen. Group of 1 sulfur, 4 oxygen. Group of nitrogen, 4 hydrogen. Group of 1 chlorine and 3 oxygen. This is called the chlorate. You may have this one, C2O4. This one is called the oxalate. You may have this S2O4 O3. This one is called the thiosulfate, and the others so many. So what I mean here is this radical is a group of 2. 2 sulfur and 3 oxygen combined together, and all of these act as a single atom. Say hydrogen, oxygen is like this one. So they are combined together and they act as a single atom. You may have this one. This is called the carbonate. This is called the carbonate. We may have this one, hydrogen carbonate. You see, it's called hydrogen carbonate or bicarbonate. This is one word, hydrogen carbonate. Hydrogen carbonate. Okay. You may have this one, hydroxide ion. Hydroxide. Hydroxide ion. You may have this one. This is called nitrite. Nitrite. This is nitrate. Nitrite ion. So you may have this one. This is called the cyano. This is cyanide. Cyanide ion. We have so many groups. You may have this one. It's called sulfite. So, and the others so many. So these are the radicals. So now you have to know how to differentiate between valency, oxidation number, and the radical. So valence should have no any positive or negative, while oxidation number has positive or negative, and the radical either all radicals have negative ion except for ammonium ion. So for example here, this is the oxidation number -1, but the valence is 1. Oxidation number -2, valence 2. Oxidation number +1, but valence of 1. Oxidation number -1, but valence of 2, valence of 1. Oxidation number -2, valence 2. Oxidation number -2, valence 2. Oxidation number -2, valence is 2. Oxidation number of -1, valence is 1. Oxidation number of -1, valence is 1. Oxidation state of -1, valence is 1. Oxidation state of -1, valence is 1. Oxidation state of -2, valence is 2. Oxidation state, oxidation number is the same thing. Oxidation number -2, oxidation state number -2, while valence is 2. Are we together? Yes. So that is how to differentiate between valence, oxidation, number, and radical.